Welcome back. This module is going to cover monitoring and troubleshooting for transport. There is a lot to talk about when it comes to monitoring and troubleshooting Exchange transport. For this module, we're going to look at some troubleshooting tools that you can use, how to look at transport queues, how to use protocol logging, how to perform message tracking, and also how mail flow is impacted by some other common problems. Let's start with troubleshooting tools. Now, good troubleshooting tools are going to help you to diagnose problems by providing information to you that you can use as part of your troubleshooting. The nature of transport problems is such that no single troubleshooting tool is going to give you the full picture. You will often need to combine the use of multiple tools that test different aspects of mail flow or that test mail flow from different perspectives to give you the full picture when a problem is occurring. Some of the tools that we'll look at in this module are native to Exchange or Windows, and others are external or third-party tools. Whether you're preparing for the exam or just trying to improve your troubleshooting abilities, these tools will be helpful to you. DNS is a critical part of mail flow, as we've seen, since mail flow can't work without the MX and the A records hosted in our DNS zones. Windows ships with the NS lookup tool, and of course PowerShell also includes the resolve DNS name commandlet. Those two tools will generally be used from workstations or servers that you control, usually within the network. So for external testing, you can use MX Toolbox to test for MX records and various other email-related DNS tests, and also What's My DNS for testing DNS propagation around the world anytime you make a significant DNS change to your public DNS records. You might be thinking NSLOOKUP and resolve DNS name are basically the same thing. My personal view is that you're better off using PowerShell and resolve DNS name so that you can do neat tricks like remoting to multiple servers to check what each of them is resolving a domain's MX record as, because they might be getting different results due to caching or querying different name servers. And you can also capture and use the DNS information in scripts and tools of your own. Testing SMTP connectivity is also important when troubleshooting. Often you'll find two servers are perfectly healthy, but there's something in between them on the network that is preventing connectivity, such as a routing issue or a firewall. Even some endpoint security software that gets installed on servers will block SMTP traffic, which obviously is not useful for Exchange servers. Telnet and Traceroute are reasonably well-known tools. Telnet will make a connection to a port that you specify, such as TCP25, and you can issue SMTP commands to test things even further once you've connected. Traceroute will show you the network route to the destination, although it's not perfect because even when a route is working, sometimes the ICMP packets will be dropped at one of the hops along the path, so Traceroute may show a problem that doesn't really exist. The PowerShell commandlet test net connection can do a similar job to both Telnet and Traceroute, except you can't issue the SMTP commands like you can in a Telnet session. However, you can combine test net connection with resolve DNS name and do neat tricks like checking connectivity to every MX record for a domain with just a single PowerShell command. As far as external connectivity tools go, MX Toolbox also has SMTP connectivity tools in addition to the DNS tools, and the Microsoft Remote Connectivity Analyzer is an externally hosted service that you can use to test inbound SMTP connectivity as well. An advantage to testing with the Remote Connectivity Analyzer is that it provides a complete end-to-end test of mail flow from the internet to an internal mailbox. So let's take a look at a demo of the Microsoft Remote Connectivity Analyzer in action. You can access the Remote Connectivity Analyzer at the testconnectivity.microsoft.com website. Among the Exchange server tests is the option to do an inbound SMTP email test. And all you need to do is provide an email address that you want to test. The first time you use it, you will need to fill out this CAPTCHA, and then you get a 30-minute session without being re-prompted for that verification. So we'll go ahead and perform that test. And after a few minutes, we get a result. In this case, the connectivity test was successful, But it's more than just getting that green tick. If you expand the full results, you actually get to see some interesting information that shows you the complete process that it went through, including all the DNS lookups involved, the initial connection to TCP port 25, and also information about the SMTP session. And lastly, for good measure, the tool also performs an open relay check. The remote connectivity analyzer sends a real email. You will actually receive that test email in the mailbox that you sent it to. And just out of interest, let's take a look at those message headers. We'll go back to the remote connectivity analyzer. This tool also has a header analyzer similar to MX Toolbox. And after analyzing those headers, we can actually see the route that email took, starting at testexchangeconnectivity.com, reaching the Edge Transport server, which passed it into one of the San Francisco Exchange servers, was then transferred to another San Francisco Exchange server, and then across the WAN to the New York Exchange server, where the mailbox was hosted at the time. And if you think back to that original diagram of the transport pipeline, well, there it is in action. Email coming in, passing between multiple services on different servers, and then finally reaching the destination mailbox. In this video, we'll look at transport queues. Exchange servers that host transport services queue messages for delivery. This is useful for situations where the destination server is unavailable for some reason. Rather than immediately drop or reject a message that can't be delivered, the server will hold the message in its queue and retry at regular intervals. But those queued messages will eventually expire. The default message expiration is 2 days, and you can increase that using the set transport service commandlet. Just keep in mind that the longer you're willing to queue messages for, the larger the transport database will potentially grow. The queuing of messages means that you will often encounter troubleshooting scenarios where you find messages sitting in transport queues, and this may be due to a variety of problems when you consider all of the factors involved in email delivery that we've learned about in this course so far, such as network connectivity, DNS, firewalls, receive connector settings, anti-spam settings, and so on. If any of those elements are experiencing a fault, a misconfiguration, or some kind of interruption, then you can expect to see queued emails. So we'll go into the Globomantics environment and have a look at viewing transport queues. In Adam Wally's sent items, we can see an email that was sent to an address of bob@contosoholdings.com. Now, Bob claims he hasn't received the message and he's told Adam that he should send it again. Adam, of course, has contacted IT support and asked Dave, the systems engineer, to look into this email that was never received by Bob. Because the outbound mail flow for Globomantics goes through an Edge Transport server at the moment, Dave decides he's going to log on to the Edge Transport server and check the transport queues. And he can do that by running the get queue commandlet. And immediately we can see that there is a queue that looks like it's for contosoholdings.com as the next hop domain. And it's currently in a retry state with one message in that queue. Let's look at a little bit more information about that queue. So again, yes, there is one message stuck in that queue at the moment, and the last error field is telling us that the issue is DNS related. There's a DNS query failure. The error is info no records, which probably indicates that there's either missing DNS information for that domain or perhaps missing the MX records. So by viewing the queue, it revealed very useful information that would certainly help move this problem towards a resolution. So now let's get into something a little more advanced and look at protocol logging. Protocol logging is an option that can be configured on send and receive connectors. Protocol logging captures the SMTP conversation that is occurring between two hosts or two devices. Because the protocol logs are capturing what happens at the very first stage of the SMTP connection, they'll capture errors and other useful troubleshooting information before an email message even enters the transport pipeline. So in that sense, protocol logs are useful for troubleshooting from a server perspective any connectivity issues that might be occurring. Each service on the Exchange 2016 server has its own set of protocol logs and protocol log settings. So the front-end transport service has one set of logs stored in the C program files folder under a subfolder called front-end, and there's a subfolder in that protocol log folder for receive logs and a separate one for send logs. What that means is that the service will log protocol logs for receive connectors to the receive folder and send connectors to the SMTP send folder. The same is true for the transport service, which logs to a folder named hub instead of front end. The folder name hub is just a carryover from the Exchange 2010 days when the hub transport server role existed, which was a role that performed much of what is now simply the transport service in Exchange 2016. For both services, there are also retention settings that you can manage for the protocol logs generated by each service. By default, up to 30 days or up to 250 megabytes of log files are stored, whichever comes first. In a high traffic environment, you're likely to exceed 250 megabytes within a few days. So increasing the directory size limit to more like 4 gigabytes would be recommended. You can increase the log retention by running the set transport service or set front-end transport service commandlets. And remember that send and receive logs are configured separately. Obviously, you want to be sure that sufficient disk space exists to store the maximum amount of logs that could be retained. So for example, if all of the receive and send max directory sizes for both the front-end transport service and the transport service were set to 4 gigabytes each, you would need to account for up to 16 gigabytes of total protocol log size on that server. By default, the only two receive connectors that have protocol logging enabled are the default front-end connector and the outbound proxy front-end connector. All the other receive connectors that Exchange Setup creates or that you create yourself have protocol logging disabled by default, as do any send connectors that you create. So we'll go into the demo environment and take a look at how to configure protocol logging on send and receive connectors. On the San Francisco Exchange server, let's take a look at the receive connectors that are configured on the server. And in that output, we can see that the relay connector does not have protocol logging enabled at this point. So it would be pretty useful to log the SMTP connections that are hitting that relay connector, and that'll help with troubleshooting any issues with devices that perhaps you're expecting to be able to relay but are having trouble. So use the set receive connector commandlet, provide the full name of the receive connector, and set the protocol logging level to verbose. The two settings are none or verbose. There's no on or true or false. Well, now that that's enabled, let's see if we can generate some SMTP traffic so that the protocol logs have something to look at. We'll use the domain controller and just get a command prompt open and do a telnet test. So with that simple message sent, let's go back to the Exchange server and see what that looks like in the protocol logs. So on the Exchange server, those protocol logs are stored in the program files, Microsoft Exchange Server, version 15, transport roles, logs, front end, protocol log, and then finally SMTP receive. Now there are a few log files in this folder already because remember by default at least one of those receive connectors is already configured for protocol logging. We'll just sort those by date to get the latest one. And by scrolling to the bottom for the latest entries, there we can see basically that whole SMTP connection just as we saw it in the telnet session a moment ago. So if there was going to be a problem such as an SMTP protocol error, you would certainly see it here in these logs. And again, that would be very useful in any troubleshooting situation. Now let's look at another use of log files, which is message tracking. Message tracking is an Exchange feature that records detailed log files of email traffic as messages are transferred between Exchange servers within the organization and between different roles, services, and components on individual servers. In other words, message tracking logs record what happens to a message as it passes through the transport pipeline. Tracking of email messages is somewhat of a sensitive topic these days. So let me just point out now that message tracking doesn't record any message contents other than the message subject. And you can turn off message subject logging if you need to. The rest of what is recorded in terms of metadata about the email messages themselves are details such as the sender, recipient, date, time, and overall message size. Message tracking is useful for answering the question, where did that email go? For example, when someone sends an email but the recipient never received it, or when someone hasn't received an email that they are expecting to receive. Now, obviously, message tracking can only track emails to the boundary of your organization. Once an email leaves your organization, message tracking will record no details about what happens afterwards. At best, you can look at the protocol logs on your send connector and verify that the SMTP connection was accepted by the other party, but nothing beyond that. Remember that the front-end transport service is only a proxy for SMTP connections, and it performs no logging other than protocol logging. So there's no message tracking log configuration for the front-end service, only for the transport service. Similar retention options exist for message tracking, as they are also seen for protocol logging. You can disable subject logging if necessary, or disable message tracking logs entirely. Disabling message tracking logs is done on a per server basis, and there's no additional configuration at the connector level to worry about. When you're performing message tracking log searches, we use the get message tracking log commandlet, and we can search based on sender, recipient, the message subject, the message ID, and also within date ranges. So let's go back into the demo environment and we'll take a look at searching message tracking logs. The message tracking logs are stored in the file system in the same path, so C program files, etc., and we go all the way to transport roles and logs, and then this message tracking folder actually contains the message tracking logs themselves. Now, these are human readable log files. You can just open them and take a look and maybe even import them into Excel, and you can look at them that way if you like. But the real power comes from performing message tracking log searches. So let's use the example of the email that Adam Wally sent to Bob at contosoholdings.com. If we just run the get message tracking log commandlet, it will return results from the local server. So there's lots of those mail delivery probes there. That's managed availability doing its probing of health mailboxes. And even on a server where there's no real mail flow occurring, you're going to see a lot of those managed availability probes. So there's quite a lot of noise to filter through, which is why we need to be a little bit more precise with the message tracking log searches. You'll also notice that there's a cutoff point at which not all results are displayed. The maximum is 1000, and you can set that result size to be much larger or even to be unlimited if you need to. Now, in this multi-server environment, we actually want to be able to query multiple servers at once. So let's pipe the output from get transport server into get message tracking log, and we'll also refine the search by choosing the sender, Adam Wally at globomantix.biz. Now, I did get a warning there at the start. I was using get transport server, which will work, but that's a deprecated commandlet, and we should use get transport service. There's also an error at the very end because this particular session can't connect to the edge transport server, which is sitting in the perimeter network and is not a domain member. Now again, there was a lot of results there, and even though we can actually see some Bob at Contoso Holdings results in those logs, I think we can refine that even further. First, I'll fix up my use of the correct commandlet here. I'm going to capture the results into a variable called messages. And at the end of the get message tracking log command, we'll also tack on the recipients parameter and specify Bob at contosoholdings.com. So we're refining this search even further, and just for good measure, let's say result size unlimited, just in case. And again, we can ignore that error for the Edge Transport server. So let's see how many results were captured in that variable. There are 15 entries. Let's take a closer look. Well, there's a series of events, so we can see that there was quite a lot of events logged for this one message as it passed through the transport pipeline. Now, out of interest, I wonder if those events are actually appearing in the correct order. Well, it looks pretty close. They may in fact be there in the correct order. But if we want to be absolutely sure, you can just sort them by timestamp. Now, in this default output, we're not seeing all of the information that the message tracking logs contain. If we pipe that data into format list, we'll actually get the full amount of information there. Now, that is a lot to look at. It can be a little bit difficult to go through it all, but if we just scroll up and take a closer look at some of it, interestingly, we can see queuing of the mail for redundancy. So this is a high availability redirect. That's shadow redundancy at play. So it's interesting to see that shadow redundancy events are also captured in the message tracking logs. Here's some log data that shows us that a connection was occurring from New York Exchange 01 on 10.1.101.6 to San Francisco Exchange 02 on 10.1.100.7. So that indicates that it was the passing of the message from one server to another, and we even see some information about which connector ID was involved in that connection as well. Here's another transfer of the message, this time from San Francisco Exchange Server 2 out to the Edge Transport server. So you can see that it's actually reasonably easy to narrow down a search in the message tracking logs and then slowly work your way through the information looking for what happened to that message as it passed through the transport pipeline. There's all kinds of useful information there, like timestamps, so you'd be able to spot delays in processing of email. You can see which connectors were involved, which servers and their IP addresses, and even recipient status and error message information as well. Now, of course, almost every troubleshooting scenario is going to be different in some way. There's a lot of variables at play, there's a lot of different tools that can be used, and going through an exhaustive list of every possible troubleshooting scenario would take too many hours and wouldn't be productive. But in this last video for this module, let's go through some of the common problems that will occur in an Exchange server environment, the signs that you can look out for, and what you can investigate to resolve them. First, we'll start with the remote domain configuration. Remote domains define settings for message transfer between your organization and other mail systems. Remote domain configuration basically applies to outgoing messages. You can control settings such as message formats, which is useful if you know that a particular domain only supports a specific content type, such as plain text. Then you can configure a remote domain entry for that domain, and Exchange will convert all outbound messages to that domain into plain text. Remote domain configuration can also control automatic replies, such as out-of-office replies and non-delivery reports. You can even control whether those NDRs are sent with or without diagnostic information. And the command that you can use to look at the configuration is get remote domain. So if you're seeing inconsistent behavior with a particular external domain, look at your remote domain entries using the get remote domain commandlet and just have a look for any clues or inconsistencies that would explain the problem. Back pressure is also a fairly common issue. Back pressure describes a resource exhaustion condition for Exchange servers that leads to a server actively refusing some or all connections or email delivery attempts. The overloaded state is based on a series of resource utilization metrics. Free disk space on the drives that store the transport queue database and logs, uncommitted database transactions in server memory. In other words, too much is happening at once and the server needs time to get things back under control. And that could be due to a big spike in message volume that has occurred all of a sudden. Memory utilization by the transport service processors, and overall memory utilization for the server as well. Each of those metrics is individually measured, and each can cause the server to go into a back pressure state. The server will be in one of three states. Normal, which means all is well and the server is performing its role as intended. Medium means a resource is moderately overutilized and the server begins limiting some connection types. And high means a resource is severely overutilized, the server ceases to accept any new connections, and the most common signs of back pressure include SMTP error 452 4.3.1, insufficient system resources. The other signs of a back pressure condition are the following entries in the application event log. 15004, which means an increase in utilization, for example, from normal to medium. 15005 means a decrease in utilization. 15006 means high utilization for disk space, and 15007 is high utilization for memory. Back pressure is ultimately a symptom of server sizing or performance issues, and the server goes into the back pressure state as a method of self-preservation. You should monitor for those event IDs and look for them during mailflow troubleshooting cases. If your Exchange server's public IP address gets listed on an anti-spam block list, such as Spamhaus, which we looked at earlier, it's going to impact your ability to send email to external domains. Getting listed by a block list is usually a result of sending spam or spam-like content. There's a lot of block lists available, so you won't always find that you're listed by every block list, and since not every mail server checks every block list, you might not even notice that you've been blocklisted because most of your outgoing mail might just continue to work. Most block lists will provide a reason for your listing, including some incident details, and give you the chance to clean up your issue and be delisted, unless you're a repeat offender. You can use mxtoolbox.com to query many block lists at once and see if you're listed on any of them. Should also keep in mind that it might not be your own users that are actually sending the spam, but it could be a misconfigured Exchange server in your organization that is being used as an open relay, which allows any spammer on the internet to relay their spam through your server to their victims. The tools at MX Toolbox and the Remote Connectivity Analyzer can help you identify if that is happening, and it's almost always due to a misconfigured receive connector. Some other factors that can impact mail flow in the organization, and these are going to be coming up in later videos in this course, include message size restrictions, transport rules, and also recipient configurations. So in summary, in this module, we looked at a variety of troubleshooting tools that are available to assist you with your cases. We also looked at using transport queues to troubleshoot mail flow, how to configure protocol logging, and how to search message tracking logs. And finally, we looked at some other common mail flow issues and solutions that you can consider when you're dealing with problems in your own environment. Coming up in the next module, we'll look at some advanced mail flow scenarios.